Good morning. Thank you, everybody, for making it. My name's Colin McCarthy. I'm a senior principal engineer. I work on EC2 VPC, our virtual private cloud product, and I work on crypto. And I'm here to talk about PrivateLink. Super excited. Probably one of my favorite things we've launched over the years. So if you're not familiar with PrivateLink at all, right? It's something we launched recently for AWS Services and launched this week for customer and partner services. And essentially what it is so you've got a VPC, virtual private cloud. That's your virtual network that you can run EC2 instances in, containers in, launch RDS instances, load balancers, all sorts of things. I'm sure we're all here roughly familiar with VPC. And with PrivateLink, it's designed so that services can now be provisioned directly into that VPC, right? By you or by third parties, and by us, AWS Services as well. And this builds on top of endpoints, which is a technology we had previously. So yeah, 2 years ago, we launched S3 endpoints, where you were able to essentially connect S3 directly to your VPC, have private connectivity to it, not worry about traffic going over either our backbone or the public internet and so on. It was all using the software-defined networking that's built into VPC. And the difference with PrivateLink between that and the previous version of endpoints is that PrivateLink uses private IP space, right? So a VPC, a customer, when they create a VPC, can say, this is the network range I want for it, whatever makes sense for them, so that they can connect it to their own existing networks, because everything has to be deconflicted and unique. And now PrivateLink, we can all create and launch services that are provisioned into that VPC that show up as one of those private IP addresses in that CIDR range. And that's pretty cool because it makes it more compatible with other VPC features like security groups and so on. I'll explain more later. But even cooler than that still is it means it can work with DirectConnect and pretty standard network routing setups, right? So if you've got a DirectConnect link to a premises, like a data center or an office, that's using standard IP routing to say, okay, well, from the office, I route 10.1/16 to the VPC and vice versa. And because the PrivateLink endpoint, because the service is launched with a private IP address, it's just reachable. It just works, right? It's very easy to set up in that way, compatible with all sorts of existing network setups. And that's one of the reasons why we're super excited about it. And that's what PrivateLink is in a nutshell at a network level. And so this is a deep dive session. So what I'm gonna focus on, right, throughout this talk is mostly the data plane and mostly the kind of tips and tricks that we've come up with in working with customers and partners in our beta period, how to use this efficiently, how to integrate it into existing setups, how to use it in a multi-tenant way, and so on. And not so much just about the nuts and bolts of how to configure PrivateLink in terms of which APIs to call or which console to use. And that's because that's pretty straightforward, right? If you want to create a new service and expose it with PrivateLink, you can actually do it quite quickly with the console. And the APIs are all very straightforward to follow, and there's documentation and so on. So we launched PrivateLink for AWS Services earlier this year, 2 months ago, I guess now, or sorry, 1 month ago, I guess now. And we launched with 5 services available on launch day. Those are up there. Kinesis, a super exciting one. Lots of people wanted to be able to have Kinesis directly in their VPC, using it for all sorts of stream processing. It's really cool. We also have the EC2 APIs, right? So the API that you call to launch instances and so on. The API that you call to manage load balancers. And EC2 Systems Manager, which is a service we have that lets you manage EC2 instances. So together, those can actually let you manage isolated VPCs that have no external connectivity at all. we even had one of our trial users in the beta period actually set up a completely isolated ring-fenced VPC that had no internet connectivity, no direct connectivity, no VPN connectivity, no way in or out. But they could still launch instances, they could still have it do things, they could use Systems Manager to execute commands, and they could export that data to S3 or Kinesis or DynamoDB, which are all available as endpoints as well. And do useful things with a completely compartmentalized isolated VPC, which is kind of mind-blowing, really, really cool. PrivateLink works with VPC security groups, right? So when a PrivateLink service is exposed to a customer VPC or a client VPC, it shows up as an ENI, Elastic Network Interface, in the VPC with a private IP, and that can be referenced in security groups. Everything kind of works as normal. And there's support for IAM policies. You can configure IAM policies that allow or prohibit traffic in from certain VPCs and so on. And I'm sure those will be extended on a service-by-service basis as well as more services adopt PrivateLink and show up. As I mentioned, the IP connectivity is all private, right? So that kind of reduces the surface area for attack risks, right? When the service is only exposed on private IP addresses in the private network, that means there's less risk of it being hit for just simple, resource exhaustion or password cracking attacks or DDoS attacks and so on, because it's not reachable in any way, even if there are no firewall rules on a border that say that, you don't need them just because the IP space is inherently private. The endpoints, when they're created, right? So when you create a service and make it available over PrivateLink, we'll go through that in a second. They're regional construct, right? So you get a regional name for your endpoint, right? So this is what the customer sees. When they launch an endpoint, that just works in any zone and so on. We also give zonal names, so you can do siloed zonal routing if you want, which we'll see. But we take care of it all under the hood. There's actually a zonal data plane. We try to make sure that all the traffic stays aligned in zones as much as we can for resilience reasons and also latency reasons. But the customer, whoever's using the endpoints, doesn't need to know about that. It's pretty cool. So we'll take a closer look at those names, because those are probably the first area where it's worth getting a little deep on. So if I create a private link, right? So here I've created one for Kinesis in a VPC. And you can see a bunch of DNS names there on the left-hand side, right? So this is the customer experience in terms of, if you want to use an endpoint, it's really straightforward for AWS Services. You just go to console and you say, well, I want an endpoint for this service. You can nominate the subnet that it launches in, and we take it from there. And then you get a screen that looks like this, and you get these long, complicated-looking names with IDs in them. The ID actually identifies the endpoint identifier and the VPC ID. They're all kind of in there. And you get a straightforward regional name that you can use. Just put that in your clients, connect to it, everything should work. And you've got zonal ones. If for some reason in your architecture you want your clients to always hit their local zones endpoint, you can make that work. You'll get the best latency that way. You might get better failover as well that way, depending on your architecture and whether a service has been architected for that. But the first thing I'll say about these names, right, is you can kind of treat them like ELB names, right? So when you launch an ELB, if you've ever used Elastic Load Balancer, you also get a very similar long name with an ID in them. But people don't tend to use those names directly, right? Don't tend to put those in browsers or anything else. They tend to CNAME or alias to them. And there's good reasons to do that, which we'll cover in a minute. One reminder on all this, so those zone names had the zone, those zonal names had the zone name embedded in them, right? So you saw like US West 2A or US West 2B and so on. Those zone names are from the perspective of the customer or the account that created the endpoint, that launched the endpoint. But those can vary between accounts, right? So two accounts, my A is not the same as somebody else's A. My B is not the same as somebody else's B, and so on. So you can't put too much weight in that letter. It's just an abstraction. And later, when we see how we can use this between providers and clients, the same is true, right? What the provider sees as A may not be what the client sees as A. You shouldn't have to worry about that too much, but if you're trying to debug, why latency might be slightly higher to one than another and so on, it's useful to bear that in mind, right? That my A is not the same as the other A, and maybe I get the fastest latency to the one that is D and so on. As I mentioned, the data plane for all of this, all of the routing, all of the magic that's under the hood is happening zonally, right? So all this traffic is managed by us, and we glue everything together so that different accounts and different VPCs can talk to each other. But that's happening in each zone, kind of autonomously and in an isolated way in each zone. So the idea there being to make sure that our zones are resilient and would always fail independently if there were ever any kind of failure, and not coupled in any way, not try to have any kind of multi-zonal dependencies. That's baked very, very deeply. We don't have, at the moment, any kind of cross-region component to PrivateLink. There are ways it's possible to make it work. There are constructs and there are things you can do, and we'll actually be making it slightly easier over time so that you can make PrivateLink connectivity work across regions. But it's something we're pretty wary of in terms of, well, if you do that, if you have a setup in region A that's now depending on a service in region B, that now means you're not really getting the resilience benefit of having two regions, right? Like the region B could now cause an issue in both locations. Also, if you've got data sovereignty concerns, right? If your data has to stay in a particular, legal jurisdiction or whatever, it can be a bad idea to have it leak and go across the services that are elsewhere. So that's something to watch out for. What we built this for, so that's for AWS Services, right? That's what we launched a few weeks ago. But what we launched this week on Wednesday was PrivateLink for customers and partners, right? We're giving the same capabilities and really, honestly, the same APIs, the same pretty much everything to anybody with an AWS account. So the idea is anybody who would like to vend a service in this way, whether it's between two different parties, right? Like SaaS vendors who have services to vend, can now do this, right? They can run and manage their service, but expose it into other people's private networks, which is very powerful. And we have an AWS Marketplace integration for that. So there's a simple discovery mechanism that just lists all of the services a customer could use, and it's got integrated billing to make it easy. You don't have to use the marketplace, but it's there if you want the easy discovery and billing. And it's also useful for compartmentalizing big setups, right? So if you've grown to the point where you'd like to have several VPCs, maybe one per service or one per team, you can use PrivateLink to glue it all together, right? You can run one microservice in its own VPC, maybe with its own account, and that can talk into maybe a central VPC where other software lives, which is pretty cool. And then, and so the way all this works, right, what's actually happening under the hood is that PrivateLink is kind of coupled, it's built on the same technology as NLB, right? And so if you want to expose a PrivateLink service, you have your own VPC with your own instances or containers in it, and you create a network load balancer, and that load balances traffic at the connection level. So network load balancer is an L4 load balancer, just handles TCP connections natively. And that takes care of routing traffic. It takes care of health checking instances, making sure your application's available, and so on. It also gives you metrics and visibility into your application. and the performance of everything. So it's kind of an entire management platform in that way. So that it's like a fairly normal NLB, regular APIs, everything you're used to managing. You can use auto-scaling groups. You can do all the normal things you would expect. And then with PrivateLink, right, you can expose that NLB now in other VPCs, okay? And so to actually make that work and be possible to integrate it into customer setups, it also comes with kind of a lifecycle workflow that helps you manage the process of creating endpoints in other VPCs and so on. PrivateLink actually comes with a notification framework. You can create an SNS topic for your PrivateLink, and then you get events whenever another account tries to use an endpoint, tries to create an endpoint referencing your service, right? And so we have a two-way kind of consent model, very similar to peering, where both the owner of the account who is vending a service and the owner of an account who is trying to use a service both have to agree, right? They both have to say, yep, I want that connectivity to be available between the two. They each own their own networks, and they're each able to tear it down at any point too, which is pretty important. And they go through this workflow, right? But because there are SNS notifications for each stage, you can use something. You can use something like Lambda or trigger functions or whatever suits you, or your own code to take those events, decide what to do. Yep, I'm gonna let that endpoint be created. I'm gonna have the traffic flow. Now I know what the endpoint ID is. So that's pretty cool. Really helps automate things. As I mentioned a little earlier, what you want to do though, right, when you get those endpoints, when you get a topic, or sorry, when you get a message that's telling you, okay, this endpoint has been created, it's got the following endpoint ID and so on. As I said before, we give a really long, identifying name for that, which does work fine. But what you probably want to do is actually create a CNAME or a Route 53 alias to that endpoint ID, to that endpoint name at that point, so that you can give shorter and more meaningful names to your clients, right? Both so that they're just easy to remember and easy to work with, but then also so that you can, if you want to use this with SSL, well, you're going to need to have an SSL certificate that matches, which means you're going to want it in your own domain, since you can create SSL certificates in your own domain. There's a really common pattern that a lot of our customers use, which is they put all this under a wildcard SSL certificate, right? So you might have, my hello world app, right, .com, and I'm exposing that as a private link service. Well, every time a customer creates an endpoint, what I'll actually do is I'll give them a CNAME, and it'll be like customer name or application name maybe or something, myhelloworldapp.com. And they'll all be going to the same private link NLB. They'll all be terminated on the same instances ultimately. And I'll vend them all the same SSL certificate, but because it's a wildcard certificate, it'll just work, right? That's a really common pattern, makes things pretty easy. And actually takes me to my next point, right? My next piece of kind of depth worth grokking on all this. Is you can choose to use PrivateLink in either a single tenant kind of mode or a multi-tenant mode, right? We've designed it for both. So if you want to do single tenant mode, that's pretty easy. Just create an NLB and a PrivateLink per customer, right? Just one for every single one of them. And this customer gets the targets that are behind their NLB, and that's that, right? So you'll have more NLBs to manage, right, because of that, but it's completely single tenant, and if that's what suits your application, it works, right? Not all applications are ready to handle lots of different accounts or customers. But we also support multi-tenant mode, right? So you can have your instances or containers take traffic for endpoint A, which is customer A, endpoint B, which is customer B, and so on, up to very large numbers. We actually use the PrivateLink technology ourselves, and we certainly don't want to restrict how many accounts can use Kinesis or EFS. And so the numbers can get staggeringly big. It's actually harder to manage on the application side, right? Building an application that can manage all of the configuration and all of the state that's needed to handle thousands of users or accounts and so on. That's a harder challenge. But we at least make it easier at the network level. But if I build it in a multi-tenant way, right? So I've got all these instances and targets behind this shared NLB. How do I tell whose traffic is whose, right? So that's the next kind of piece of depth that we need. And we have some tricks there. So the first method is don't do anything. Ignore the network, right? If you've got traditional accounts, passwords, security tokens at application level, like if you were already running a service that was exposed on the internet, for example, this is probably what you're doing. Just do the same thing. Works, right? And we have a number of customers and partners who took that approach. Now, if you want to be a bit more, if you want to go a bit further than that and say, well, even though I know the account, I want to check that it's really coming from the right VPC, or I want to ensure that. Or maybe you don't have accounts at all and you just have the VPC. We've got some mechanisms for that, right? So the second method is, well, run a multi-tenant application stack, but use separate NLBs, kind of like that single tenant approach, but go to different listener ports, right? So, port 8000 is customer A, port 8001 is customer B, and so on. And we've seen a number of customers and partners do that because it's pretty easy to create listener ports in a lot of software, and they're just kind of set up for that, and you can use vhost techniques and so on to just kind of make that work. It integrates with a lot of existing solutions. And then the third mechanism, it's actually our preferred mechanism, but it's a bit more advanced, and you might have to patch software for this, is there's nothing in a TCP connection inherently telling you what VPC traffic is coming from. There's nowhere to put it, right? Like a TCP connection, you get the remote IP address, the remote source port, and that's all you have to go on. And those can overlap. We use the same IP addresses in many, many VPCs. So it's not enough information for you to know what the VPC was. So we actually have a preamble that we can put at the start of the TCP connection, like we insert it, and it's a proxy protocol v2 header. And we've extended that. So it's an extensible format. We worked with the folks who standardize it. And we've got our own extension to it just for PrivateLink, right? And so if you see this option in the proxy protocol v2 header, you can decode it, and it tells you what the VPC endpoint ID was that this traffic relates to. And so now you've got enough information to know exactly what the traffic was for, right? That's the disadvantage with this, right, is you have to patch the software, right? If you've got a web server or a mail server or a database server, they don't know that the first 100-ish bytes of a connection is going to be this proxy protocol v2 header, and to parse it in this way, right? So the application has to be patched to do that. That's typically not that hard. Every time we've done it so far, it's taken less than a day of software development time. It's really just finding the code where the socket is accepted, right there at the start, reading the right number of bytes, and knowing what to do with it. So it's actually less difficult than it seems. And we think easier than using like IP options or TCP options and so on. And that's pretty much that's all you really need to know to be able to run a PrivateLink service. Everything else is the same as just running behind an NLB. These are the things that are specifically different. They're pretty straightforward to do. We didn't take long with any of the customers and partners we worked with in our beta program. So I'm actually going to invite one of them up on stage right now, Matt Glickman, who is from Snowflake, an AWS partner. They work on big data solutions. To go deeper on more of the why, right, and more of the benefit that they are seeing from PrivateLink. I'll just bring them up. Thanks, Matt.
Thank you. Good morning, everyone. Thank you, Colm, the AWS team, for inviting us to be here on launch day. This is a big deal. Right? This is a big deal for Snowflake and our customers, but it's also a big deal for the industry in general, but particularly for SaaS solutions that are running on AWS today. The funny story is we've been hearing from customers for years wanting to be able to run in their own VPC. We're a SaaS offering. There wasn't an ideal solution for that. And then a couple of months back, one of our regular cadence meetings with the Amazon team, they sort of mentioned of all the other things that are coming down the pipe. We have this PrivateLink thing that we're trying to launch at reInvent. Would you want to be a launch partner? It was like I thought they were joking. This was like a huge deal. And I'm like, of course we want to be part of this launch. So we're going to talk about a little bit about how and why it's important to Snowflake and our customers. But I think everything that applies should be applicable to hopefully many more people in this room of why it's a big deal for the industry as a whole. So just quickly, what Snowflake is. We're a data warehouse as a service offering. We want to run on Amazon, targeted at big enterprises, scale in multiple dimensions. This is what our architecture looks like at 100,000 feet. But basically, using S3 for storage, be able to have compute independently scale, detached from storage, so you can scale for unlimited size of data, unlimited size of workloads, all independently, no non-contention, with a service layer on the outside that can also scale independently. All of this basically allowing customers to have a single source of truth with as much compute as they want to run at it, with dedicated SLAs between them, for true elastic scale for all the users in their enterprise. Prior to the spring of 2017, these were Snowflake's offerings, from a standard offering up through an enterprise and then to an enterprise for sensitive data offering. Really targeting different customer requirements for security and offering it for different, whatever they need, whatever they feel comfortable with, to be able to use this service for their workloads. But taking a step back, Snowflake has always thought about enterprise security from first principles. Right? I think this is the kind of thing that should apply to everyone here, and it's not unique to us. And the first two things that we thought about as the first core principles were encryption matters at rest and in transit, and encryption is only as good as having ultimate control of the encryption keys. Right? Talking about encryption is not useful if the key is not managed by the right audience. So today, or actually in the past, our Snowflake's deployments basically looked like we ran a multi-tenant pod within a VPC that we managed in a region. Our services layer was in that pod. We had dedicated what we call virtual warehouses for each customer. And then a customer would connect and go over the internet to connect to this service. And that would be our standard offering. On top of that offering, for more sensitive customers, we offered what we called ESD, or Enterprise for Sensitive Data. Very similar, just encryption all the way through from the client all the way through our service, through all the nodes of our service, encryption all the way back and forth. But the thing that this offering added, in particular, in addition to encryption at rest and in transit, was what we call tri-secret encryption keys, or basically our take on customer-managed keys. So think about it as, I like to think about it as like the nuclear sub kind of mode of how to deal with encryption, right? So for any access for a customer coming in to access their data in this model, there's 3 secrets involved. There is the customer with their key managed, in this case in KMS. There's Snowflake, which has its key in an HSM. And then the user comes in with their credentials. All 3 of those secrets have to be present at any moment in time to access data, to write data, and so on. If any of those secrets goes away, the data is inaccessible. right? So this was, a significant kind of launch forward, and this is where we were. Then enter Capital One. As much as I'm sure everyone in this room is aware, Capital One has made aggressive moves to be all in on AWS. And for their workloads, the data warehouse workloads, they turn to us to basically help them migrate from their traditional warehouses to an all cloud offering. So back to first principles, working and partnering with Capital One, what we basically realized is that we need a new principle when thinking about it from first principles, which was dedicated, right? And it was really great when we worked with them on understanding why, right? And the thought process was, encryption key management is great, but really, in order to have a clear line of sight on security, wherever that key is going to be used, it should be in a dedicated a dedicated virtual machine all the way through, so that there is no multi-tenancy wherever that key is going to be used. So then we added a new offering into our building upon everything else we talked about, which we call Virtual Private Snowflake, which basically allowed a single tenant version on top of this already secure environment. So everything else stays the same. In this case, it would be Capital One connecting to us and using a proxy to connect between these two VPCs, right? Which is great and it's secure, but it was not ideal from a just configuration and management point of view. So why I'm here today, why we're super excited about this, is that PrivateLink offers us, for our customers, private network connectivity, right? As the fourth core, from first principles, the fourth core ingredient to enterprise security in the cloud. So now, with this model in place, both for a multi-tenant offering, Snowflake just appears in the customer's VPC. And then with our dedicated offering, we were able to deliver a true single-tenant service that connects to our security-conscious customers as a direct connection in their VPC without any internet connectivity involved. This is huge. And what really comes to mind, and Cole mentioned this, and I think this is critical, is PrivateLink really is, in effect, was the missing link in being able to deliver between on-prem to the cloud to SaaS services, all without going over the internet. Our prediction is that this will be a significant moment where the going from on-prem to the cloud is no longer a big jump from going onto the public cloud. Should now make this whole migration much easier and the line much more gray. So again, these four core principles: encryption at rest and in transit, ultimate control of keys, dedicated instances wherever those keys will be used, and private network connectivity all the way to the end. Thank you very much.
Thank you very much, Matt. Okay, so we've seen a bit of kind of how straightforward this is to use. From a client's perspective, it's very easy. A few clicks in the console. And from a provider's perspective, it can be less than a day of work to set all this up. But there's a lot under the hood that's making it that easy, right? There's a lot, and so Peter DeSantis back on Tuesday night, which seems like a long time ago now, spoke about Hyper Plane, which is this system, an internal service that we built that Amazon Elastic File System, Managed NAT, Network Load Balancer, and PrivateLink are all built on top of, right? And as you mentioned, it's kind of the evolution of the S3 load balancer. We took the design for the S3 load balancer and we extended it a bit to run on top, to run in EC2 and also on EC2. So Hyper Plane, it's actually a distributed system that's running on regular EC2 instances that's doing distributed transactional connection tracking, right? So what's actually powering all this under the hood is that we're doing connection tracking in VPC A and connection tracking in VPC B, and we can glue them together because we have enough state for that. And Hyper Plane does all the translation that's required in between. It's not acting as a proxy, right? It's not like a traditional application server or appliance where it's terminating a TCP connection and then creating another one to the back end and so on. It's actually, packet by packet manipulating everything at enormous scale. We built this for S3 scale, like really, really, really big numbers, really low latencies, really high performance, and very high reliability. In fact, because EFS runs on it, and because connections to an NFS server can last for months and years, it has to be extremely highly available. We don't want to tear down somebody's connection to a file system. So everything's distributed, everything's replicated, right? Every new connection, every time a PrivateLink connection comes in and we figure out which backend it should go to and do all the translation, that's all being robustly, transactionally recorded in memory on, a bunch of instances, right? So, and if an instance were to fail, or 2 or even more instances were to fail, that connection still wouldn't be interrupted. There's a lot of resilience built into the system. It's pretty cool. And not only can it rewrite packets, right? Not only can it do all this translation to glue everything together, but actually can insert new ones, which is how we do the proxy protocol v2 header. We're actually able to put, extra data inside of a TCP connection and still glue it all together and still make everything work, so that it all shows up, right? And when I showed you that diagram earlier, where, logically, when you use our services, it feels like you've got an NLB, like a normal NLB, and then you kind of adapt it with PrivateLink to show up as endpoints in the other VPC. In reality, they're the same thing. It's the same system. PrivateLink and NLP, it's just the same code all running on Hyper Plane, doing the translation there that's required between the VPCs. And it's pretty cool. We're pretty excited about it. And we're pretty excited to see what you're all going to build with it. But that's essentially what's happening under the hood. So we've heard about how it's possible to build like SaaS-style services and vended third parties. But I mentioned earlier we have that other use case too, right? Where you might grow to be big enough in size that you've got multiple VPCs and you want to manage all the connectivity between them. And I'm going to invite on stage another co-presenter, Larry Hook from GE. So GE is a company I just personally admire, right? They kind of apply technology and engineering to an unbelievably broad range of problems, which is what I aspire to as an engineer. So I'm excited to hear about how they're using PrivateLink. So I'll hand over to Larry. They're I think definitely count as a big company. Thank you.
This mic is mine. I think it's still on.
How's that? No? 1 second.
Better? Okay. Okay. Oh, let's try that again. Larry Hook. I'm a principal infrastructure architect at General Electric. Hopefully most of you know General Electric. If not, a lot of folks know us from our consumer brands. But in reality, we're one of the leading multinational digital industrial companies. We operate in multiple lines of business. Digital, which is our software arm, aviation, power, healthcare, transportation, GE Current. We operate in 170 plus countries. We've been on this multi-year cloud journey for like 4 years now. Migrated about 2,000 applications. And the size and scale of GE basically allows you to experience any cloud journey scenario that you can imagine. When we first started off, we did cloud parties. We migrated like 50 apps in 30 days. Later, as we got a little bit more sophisticated and started worrying about our applications a little bit more, we started doing multiple risk profiles and trying to understand what kind of applications we were moving into the cloud, what were the risks associated with moving those in, classifying our applications so we can work on different types of risks and moving those. And we've migrated different ways. We've done lift and shift. We've done some re-architecture work. And as new commercial opportunities come up, we do cloud native migrations or builds right on the cloud. My team's the public cloud team within GE. Our principal charter is to vend cloud environments to application teams, specific groups, whoever actually wants to start taking advantage of all the cloud capabilities. Our model's self-service, so people can opt in and start using the cloud environments. And our principal, guiding principle is to get yourself a cloud environment and then get out of your way. We don't want to overburden any of the application or development teams with an excessive amount of governance and bureaucracy. And we really think PrivateLink is going to help us do that a lot better. We've been doing this for about 4 years, so we've gotten through several different types of VPC designs and account designs. And that's, I think, pretty much it for this one. Our current environment. So Colin was talking about if you get really, really big, how can PrivateLink help you? We've got over 300 accounts, 6 or 7 regions. Everybody's using multiple availability zones. All of those accounts are peered back or connected back to on-premise with DirectConnects. Some of our cloud-native applications have 4 or 5 different accounts peered together to provide capability throughout all of those. But most of our corporate tool set to help manage, track, govern all of this stuff lives in on our on-premise environment. Getting those tool sets out to all those VPCs, extremely complicated. Routing decisions, firewalls, a lot of the stuff that you're familiar with as traditional IT folks that can get into the way. So our intent is we want to provide secure, easy connectivity to all these corporate services to your development teams without having to burden them with setting up new firewall rules, calling the networking team to figure out how they get their best path, any of that stuff. So our intent is to move all of these services into the provider side of the PrivateLink thing the diagram that you saw, and allow application teams to subscribe to the services that they need based on their risk profile. So if they need central authentication, whether they need logging aggregation, whatever that kind of service is. It allows us to simplify our routing, simplifies our attack surface from a firewall perspective because all of those firewall rules are now getting condensed down into the provider VPC. It allows our application teams to become more cloud native. A lot of our rules in the VPC today are based on making sure those tools work. And a lot of the application teams, why do I have this route? Why do I have this NAT call? They're like, I don't know. But now they can see, oh, I want to use this service for this risk profile. I'm going to set up the NACL correctly. I'm going to set up the security group correctly. They want to do the right thing. We just need to give them a simple way to consume that and then get out of their way. We've probably got about 25 of these services that are really core. We've already been doing a lot of the things that Colin have talked about. So we use internal Route 53 DNS zones to register those services. So the way that PrivateLink works versus V1 of the endpoints versus V2, so we can just continue to use DNS rather than having to add S3-like endpoints to the routing tables, which is a good thing. And we like using DNS. So everybody's used to using DNS to get to a lot of these corporate services. It's something that's pretty ingrained. I'd also like to call out to the beta team that we worked with. We had 3 or 4 POCs where we tried to get 3 or 4 of these services up and running. We were really excited. We started, oh yeah, this is great. Let's start creating endpoints, updating the routing tables, and we were like, oh no, it's private IPs. We got to figure out how the private IPs work. Where are we going to put NACLs? What are we going to do for routes? That kind of thing. So they were with us 100% through that learning experience. It was a really good experience. I'd like to say thanks. And that's it. Thank you very much.
Thank you. Great. So we've seen how easy it is to get started. As I mentioned, everything just kind of feels like an NLB from the service provider's perspective. It's, you know, like hosting an existing service. We're giving the same capabilities now to customers and partners that we use to vend services to VPCs. Very, very, very powerful. It opens up new kind of opportunities, right? Like it's possible to use PrivateLink to serve on-prem and intranets and just on-prem and intranets, right? Like creating these empty phantom VPCs on behalf of a customer that don't have any instances in them. DirectConnect to a customer's premises. And actually be able to vend a service that shows up as a private IP address just works from their network, right? And it can be made really simple, right? When you use tricks like just keep it all in your own managed, you know, regular public DNS, everything just works. You don't need, you know, strange hacks like people having to go in and reconfigure Active Directory servers or create VRFs and strange routing tables and all this kind of stuff. It's generally far easier to just provide a service as here's a private IP address, here's a regular public DNS entry that resolves to it. The reason we use public DNS there, even though it resolves to a private IP, is just so it works anywhere, right? Even if they're in their office, even if they're at a data center, it just works. In fact, that's how ELBs and RDS instances and so on work today. If you have a private internal ELB or an RDS instance, you know, they resolve to private IP addresses. But those DNS entries, those are public. And so when customers are connecting to them from on-prem, they just work. You know, they don't have to say, my Active Directory server for this set of domains forwards to this DNS server and go through all that rigmarole, which is really, really inconvenient. And that's probably my main tip, right? You make the DNS side really simple. And then on the multi-tenant side, take a close look at that proxy protocol v2 header. If you want to run something multi-tenant really well, challenge yourself to implement that. If you need to, it's not that difficult. And you can be up and running. You can get going. You can have PrivateLink services available, you know, super quickly. All this is now GA. You can go launch, start using the console, use Marketplace if you want. Hopefully it stays easy. And I'm excited to see what people will build on it over time. I'm sure it's just beginning. We launched with about 15 to 20 partners already, and just this week that's already growing. You know, we're starting to see people adopt it already, which is great. Again, thank you all for coming. If you want more detail on Hyper Plane and what's under the hood, there's actually more in the NET 405 talk, which is now on YouTube. And we'll be making some more information available over time as well about how that's structured internally. And I hope everyone's interested in PrivateLink. Thank you very much for coming.